I'm Vinay Shekhar, currently pursuing my BTech in Electronics and Communication Engineering at Pragati Engineering College. I recently completed an embedded systems internship at MHC, where I worked on exciting project designing a microwave oven system. So in this project, I developed and implemented a microwave oven system using embedded systems. The goal was to stimulate the functionality of microwave oven, including setting cooking time, selecting power levels, starting and stopping the operations, and ev- and even the safety features. So let's get into this. The main content in this PPT is introduction, embedded C, microprocessor, microcontroller, requirements of this project, the referrals and simulation of the project. So the main theme of this project is embedded system. An embedded system is basically a combination of computer hardware and software designed for a specific task or application. It can be either microprocessor or microcontroller. We can see the examples and applications of these embedded systems on the screen, like household applications, comes washing machines, smart TVs, and smart ACs, and you can see around automobiles like airbags. If we met with an accident or if we hit something, the airbag within milliseconds of the time it pops up, and seat belt, navigation system, automatic wiper, ADAS, and mobile phones, operating systems, cameras, microphones, USB, OTGs, and it's also there in healthcare, medical equipments. And let's get into the deeper into this. So block diagram of embedded systems. You can see CPU is the central processing unit, and which is connected with total all the things like sensors, AD conversion, DA conversion, AD and DA are analog to digital and digital to analog conversions, and actuators, memory, and software. Basically, a code is dumped into the microprocessor. So it processes the code and acts according to the code. And you can see memory also connected to the CPU. And according to the code we written, we get the output. So microwave oven. So microwave oven, we all know it works on a principle of conversion of electromagnetic energy into thermal energy. It is a it is an electric oven that heat and cook the food by exposing it to electromagnetic radiation. Um, we developed a thing. We developed a project. On this project, there are four modes: micro mode, grill mode, convection mode, and start mode. We can see micro mode is the standard microwave mode that uses electromagnetic waves to heat the food quickly. It is an ideal for reheating and defrosting and cooking simple dishes like vegetables or rice. Grill mode. This is the mode uses the heating coils to grill or brown the food, giving it a crispy texture. It is great for toasting sandwiches and grilling kebabs, melting cheese on the top of the dishes. And third mode is convection mode. This mode circulates a hot air evenly inside the oven using a fan. You can see this fan moving in the simulation also. So this mode allows you to bake and roast the food like in a traditional oven. So it is perfect for cakes and long time taking dishes. So cookies and pizzas or melted meats. So last mode, start mode. This is the main mode. It is used to start the cooking process. After selecting the desired mode and time power level, it activates the micro oven to begin the heating process. So embedded C. The code we write to the microcontroller, PIC microcontroller, is written in the C language. Why C language? Why C language? In embedded systems, the program code should operate within a fixed memory space to execute the code. So C offers that kind of comfort and that level of control over the hardware. So C programming can produce efficient and compact code. It produces very reliable code to execute critical tasks, and it also have the readability. Readability. It uses meaningful variable function names and comments to make the code more understandable and portable. It has the ability to run a program on different hardware and operating. It's like we can use the code in VS Code and WSL and Linux, any kind of hardware we can use operate in any kind of operating systems we can use. So it is scalable. It is used to reuse the code and can easily add modes to the modules to an existing system. So we can reuse the code and can modify code also. So reliable. It helps to reduce the software bugs and it it will provide the minimum security to the code. So almost microcontroller. So a microcontroller is a compact integrated circuit design to govern a specific operation in an embedded system. So um, it is the heart of the micro embedded systems. So a typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. So the other supporting elements can include analog to DC digital converter and digital to analog converter, system bus, serial port. So when we have to buy the microcontroller, we have to choose these four things like performance wise and price wise and applications and availability. So microprocessor, it is a programmable device that takes in input, performs some mathematical and logic operations over it and produces a desired output. So microprocessor is uh, volatile memory, like it stores for some kind of time. Uh, After the system on or off, the the memory we stored in the microprocessor will be gone. So microprocessor contains millions of tiny components like transistors, resistors, and diodes that work together and that represent a microprocessor. You can see the block diagram. Microprocessor contains ALU, control unit, register array, and uh, and the input device and output device are connected to the left and right side of the microprocessor. You can see in the block diagram and memory unit in the bottom. So the main requirements for this project that what I done in the simulation. So it includes MPLAB IDE. So in this in this uh, in this lab we wrote the code and save it and dump it to the PICSimLab. So and the compiler we are using is XC8 compiler and the simulation lab we are using is PICSimLab. So controller we are working on with is PIC16F877A and the display what we are having is 16 into 4 CLCD. By default it PICSimLab provides 16 into 2 CLCD. We have to choose for the 16 into 4 CLCD for our convenience due to 4 modes we have. So we are compatible with 4 LCD. So also tactile switch and timer 2 and matrix keypad ISR. So let's get in deep into this. So PIC microcontroller we are what we chosen is PIC16F877A. It is a microcontroller that normally used in embedded projects. So the main properties of this is consists of 40 pins and it has 5 ports: port A, port B, port C, port D, port E. And port A consists of 6 bits. It is the only port which has analog pins. And port B it contains of 8 bits TRSAB and it is a digital pins. These are all digital pins. So port C it is a TRSC. It is used for serial communication. These port also digital port. So port D 8 bits TRISD. These pins are represented in digital pins and port C. These are also digital pins. These are called TRSAE. It will work by uploading the hex file. You can see in the simulation process. You can see this uploading process in the simulation process. So you can see the PIC microcontroller architecture block diagram. So it is a diagram of representing the 40 pins of different types. You can see the each pin name on the left side and right side. You can see VDD and VSS on left and right side. So you can see the input and output pins. Size of the microcontroller is equal to the size of the data bus, and data bus is equal to 8 bits, and instruction set architecture is RISC. So peripherals of the PIC microcontroller what we chosen. You can see it consists of basic pins and the basic connections. You can connect ADC and temp sensor, temperature sensor, and GPIO, RS232, and LEDs for digital keypad, SSDs, matrix keypad, CLCD. You can see on the right side, you can see the connections like device and current flows of the device and load resistance. You can see the current and load resistance. So what we have discussed from now is a PICsim microcontroller, PIC microcontroller. Now you are seeing PICSimLab architecture. You can see it consists of a microcontroller PIC16F877A. You can see the 40 pins of the microcontroller and which are connected to desired desired connections. Like you can see the keypad of numbers like 1, 2, 3, 4. These are actually represented in a tactile switch, tactile buttons. Uh, you can call them as first tactile and second tactile and switch up like that. And you can see the CLCD. So we are using is 16 into 2 CLCD. So what we are using is a CLCD 16 into 4. You can see in the simulation process. And finally, interrupts. An interrupt is a communication. ఇక్కడ ఏం చేస్తున్నాను నేను An interrupt is a communication process set up in a microprocessor or microcontroller. Interrupts are handled by ISR, interrupt service routing. So the process of interrupts is basically a, I can explain with an example like uh, when a car met with a, when a car hit something or met with an accident, the airbags from the steering and from the backside, from everywhere, airbags pops up immediately. Like you can say the interrupt as an damage or accident suddenly occurs. That suddenly occurs, and the microprocessor or microcontroller should process that interrupt and acknowledge that request and attends to the and give a solution to the request interrupt, like blowing of the airbag to protect the members inside the car. So it's like that. So it happens in within a milliseconds. Okay. So an external and internal request of MPU to stop the processing. The MPU acknowledges the request and attends the request and goes back to the processing what it's doing. So sources of interrupts. You can see external interrupt could be caused by onboard and internal interrupt inside the microcontroller. So you can see the difference. So finally, the simulation of the project. I exit from the presentation and I'll show you the simulation. So where is it? Wait a second, I didn't open it. As I told you, MPLAB IDE we are using for programming and for compilation and debugging our code. So let it be load. So you can see here clcd.c. This was the post code I have written. Like this code is for controlling the character CLCD using PIC microcontroller. Um, you can see here. Um, you can see here CLCD write function. So the data or command to send and specifies if it is a command or instruction or a character. It seems the byte to be two parts, higher nibble first and lower nibble then lower nibble, because the LCD is a 4-bit mode. So you can also see into display controller here. It initializes the LCD with a correct setting and into CLCD function, and you can see here in CLCD function it prepares the microcontroller for communication with the LCD by setting the data port register select and enable en enable lines as outputs, calling the int display controller here int display controller function to initialize the LCD. So this is the code for LCD display, and we can see here this is the second file of code. It is basically this code is an interrupt service routine ISR for timer based countdown system using a microcontroller, PIC microcontroller. Here how it is work. You can see if statements and if else statements. The purpose of this is it handles the countdown of minutes and seconds using the timer to interrupts. And we are going to the main dot C. See here, this is the main code. This is the main control code, main control program for a microwave oven implemented using PIC microcontroller. It uses CLCD for display, matrix keypad for user input, and timer for countdown and timing operations. Here's a detailed breakdown, like you can see here. It ends here. So the program simulates a microwave oven with the following modes. You can see here with the following modes: micro, grill, conventional, start. These are the four main modes that starts I also setting in the PPT slide. Micro mode is a standard microwave heating, and grill mode is for grilling food. Convection mode is for using a fan and heating the element for baking. And start mode is for starting the timer and fan. So this is the main block of code, and we will go to the matrix keypad. Matrix keypad. This is the code for matrix keypad. You can see the function void init matrix keypad void. So this code controls the microwave oven using a PIC microcontroller with features like keypad input. Uses a 4 into 3 matrix keypad for mode selection, time and temperature settings. Modes include already said micro grill mode and convection mode, and display shows the remaining time in minutes and seconds format. Control elements like fan control, buzzer for alerts, and timer 2 for interrupt and timekeeping. So user interface, you can see in the simulation. User interface is 16 into 4 character LCD for displaying the status and options. By default, PIC microcontroller is consists of 16 into 2 CLCD. We have to opt for 16 into 4 CLCD for our convenience and the options we have. So final block of code is timers.c. You can see it is a small code. Timer 2 on PIC microcontroller. Timer 2 is typically used for precise time delays or periodic interrupts, which are useful for tasks like updating a delay generated sound or controlling motors. You can see the breakdown to this code like TSCKPSO is equal to 1, and PS1 equal to 1. This sets the pre-scalar to 1:16. A pre-scalar pre-scalar divides the clock speed and making the timer count slower. So in this case, the timer counts the once for every 16 clock cycles, and you can also see PR2 equal to 250. The timer will count 0 to 250. When it reaches to 250, it resets to 0 and triggers an interrupt if enabled. So this is the coding part, and you can ask these are of 4 kind of files. How can it be represented one kind of project? I also said in the beginning, C programming has a concept of linker. So it links the 5 kind of files into a one, and represented in the execution of PICSimLab. Wait a second. Yes, you can see the powering on the microwave oven. So I opted for the microcontroller PIC 16F 877A, and the file, we have to load the file by opting the load XR and direction, and give the direction to the board. I already uploaded, so it's not for now. So you can see the 4 modes: micro, grill, convection, and start. Okay, and the 4 files, as I told you, the 4 files here: CLCD, ISR, main, matrix, keypad, timers.c. The 4 files are represented in a one file, that is XR. You can see microwave.xr. So we load the X file, and the operation initially starts. So I'm opting for micro. So it's showing the power 900 watts. Let me wait for the seconds input. Okay, the time showing here, the minutes are stored, and here the seconds are stored. I'm giving the 5 seconds, and hashtag for enter as represented here. So hashtag for enter. So it waits for 5 seconds. So it was the first mode thing. Yeah, micro mode. It is for reheated food, reheatable food, like already done, and you can listen the buzzer sound. We can turn off the buzzer if you need, and on the buzzer if you need. So, and second mode, grill mode. I'm going to clicking the second tactile switch. These are the tactile switches, and I'm giving the time again 5 seconds, and enter. So it waits for the 5 seconds, and when it comes to 0, the buzzer beeps. So it is a convection mode. So the fan rotates. You can on or off the buzzer sound. So So this is for the grill. This is grill for grilled chicken or some kind of overheated things. It uses the coals for grilling the items. So third method, convection method. In this method, it uses the fan for evenly evenly like evenly giving the air for the item, for the food item inside the micro oven. So let's go to that also, convection method. So in this method, we have to set the temperature to some kind of Celsius or some kind of this up to this kind of temperature. So I'm giving it automatically given to the 198 centigrade. So I'm just going to enter. So it's preheating. So the time remaining here you can see 180 seconds as it given. So you can calculate 180 seconds divided by 60 is actually 3 minutes. So yeah, it is a default. By default, you have to wait for 3 minutes to complete the process. So it will preheat the item, and it will be after the time remaining goes to 0, and buzzer will sound. And I'm not waiting for 3 minutes here, so I'm just representing. So that's it for this mode. That is start mode, and we are going through that. For so it is predefined. It is a predefined time and default time. So we can't adjust the time. So it is basically defaultly put the time into 30 seconds. After 30 seconds, the the microwave oven will stop the process. What the process is micro oven is doing. After 30 seconds, the buzzer will beep, and we can wait for 90 seconds now. So let's wait. And you can see after 30 seconds, the buzzer will sound. Yeah. So these are the 4 modes that micro oven should process and process. So this is the project I have done with all the guidance that MHC is provided for me, and it was a great experience to be with MHC for a 1 month of training period. So the mentor was amazing, and it was a very great opportunity to grab it. And thank you MHC, thank you very much, and thanks for listening to this for, and thank you all. Thank you.